Hi, we're looking at converging lens ray diagrams, and today we're going to look at the one that people find most fiddly. And that's the one where we use a converging lens as a simple microscope. The rest of us would call that using it as a magnifying glass. Okay, now when you use it as a microscope to magnify stuff, if you've ever ran around like Sherlock Holmes pointing magnifying glasses at things, you realise, or possibly you won't realise, that happens when the object that you're looking at is somewhere in here. Now I'm just going to go through some of the properties that we have to associate with a converging lens here. We have an axis running through the centre of the lens at 90 degrees to the plane of the lens. We have a little point at the dead centre that we call the optical centre. We have a point 1 focal length out called the principal focus, and we have another point 2 focal lengths out. And we do that on both sides, F, 2F, F, 2F. And there's a couple of rules that we use. First we'll get an object in place. Here we are with an object set up. You can see we've got an arrow here, and we always put objects in with an arrow so that we can tell the top from the bottom. The bottom is always on the axis and the top is always the tip of an arrow. Now there are two rules for how rays can be used to help us identify where the image is. One of them is that any ray through the optical centre passes straight on. So if we rule a ray through the optical centre, it will go on undeviated. The other one is that the ray that's running parallel to the axis will turn and go down through F. And so what we want to do is add those two rays to the diagram. So we send a ray parallel to the axis, it turns and goes through F. And then we want to send another ray that goes through the optical centre. So now we have both our rays. One parallel that turns and goes through F, one through the optical centre that passes undeviated, and we'll just add some arrows to those rays to show the direction of light travel. So these are our two rays, and this is what's unusual about this particular diagram. These rays will never meet, they're diverging. So they will never form an image on a screen. This is what we call a virtual image. What we have to do is put our eye in this location and look through the lens, and our eye thinks that this line is coming straight to it and that this ray is coming straight to it. So what we have to do is find the common point back here that these two lines appear to emanate from, and that will be where the image is. So if we dot those back, we get this idea that an observer down here sees these two rays as coming from a common point back here, and that's where the tip of the image arrow is. So we add in the image arrow where those points cross, and you can see it's the same way round as the object. It's an upright image. It's magnified, and it's what we would call virtual. We have to look through the lens to see it. These rays will never form an image on a screen. We have to look back through in order to see this. And so that's how we determine the location of the image when we use a converging lens as a magnifying glass. So to recap, we start with our object, we send a ray through the optical centre which goes straight on, we send a parallel ray that turns and goes through F after it passes through the lens. These two will never meet, so we have to dot them back to a common point that an observer here thinks they are coming from. And that's where an observer looking back through the lens from this location would see the image of the object. So this is our image. This is our original object. You can see the lens has made it bigger. So the observer perceives it to be bigger than the object. If they took the lens away and just looked at the object, it would be smaller. But looking at it through the lens makes it look bigger. And this is an observation that we're all aware of. All of us at some time have picked up a magnifying glass and magnified something. So this is the final diagram for using the converging lens as a simple microscope or magnifying glass.